Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we're going to talk about absolute value. Consider me zero. When the ball goes from me to Canella, it is going from right to left. That has a negative direction. When she brings it back from left to right, it has a positive direction. Say I throw her the ball. It travels -2, and then back, well now -8, and then back 8. -8 plus 8 is 0. That doesn't make sense. The ball didn't travel 0 yards. Now let's think about absolute value. Absolute value measures distance from 0. So if I'm 0, the ball might go -2. -8, and then back +8. The first throw might be negative because it's going from 0 and left, which is the negative direction, but it still travels a distance. So we're not going to add it to the positive distance with a negative sign. I can use absolute value to measure the total distance the ball traveled. So I might throw the ball in the negative direction, but it still goes a positive distance, which is the absolute value. The notation for absolute value is 2 vertical bars. Anything in between the vertical bars is what you're looking to find the distance from 0. Absolute value is defined as the magnitude from 0. Magnitude is a fancy word for distance. So all we're trying to do is find out how far away a certain number or value is from 0. Absolute value answers the question, how far away is this number from 0? An absolute value is always positive. Absolute value is written as 2 vertical bars. These vertical bars are also grouping symbols. The absolute value bars are another grouping symbol. Let's use number lines to model what absolute value is really asking us to show. The absolute value of -8/10 tells us how far away -8/10 is from 0. A distance will never be negative. It is always positive. The absolute value of -8/10 is +8/10, the same distance from 0, but the positive value. Now let's look at the opposite of the absolute value of -8. Let's find -8 on the number line. Remember, -8 is inside grouping symbols, so we need to find the absolute value of -8 first. -8 is 2, 4, 6, 8 away from 0. The absolute value of -8 is 8, but we want to find the opposite of the absolute value of -8. So that takes us back to the negative side of 0. The absolute value of -8/10 is +8/10. The opposite of the absolute value of -8 is -8. We can use absolute value when adding integers with different signs. Let's go from left to right. -6 plus 2. -6 plus 2 takes us to -4. Without a number line finding the sum of 2 integers with different signs, we need to identify which add-in has the greater absolute value. -6 is further from 0 than 2, so the sum is going to stay negative. We find the difference of the absolute values of the add-ins, 6 minus 2 is 4, and keep the sign of the value with the greater absolute value. We don't need absolute value to find the sum of 2 integers with the same sign. They stack on top of each other in the same direction. So -4 plus 5 more negatives stays negative. It is -9. Finding the sum of rational numbers with different signs is another opportunity to use absolute value. Let's use our law of associativity. Click the link here if you want to learn more about the law of associativity. Let's use the law of associativity to group 7.5 with -1 first. 7.5 and -1. Which has the greater absolute value? 7.5 is further from 0 than -1. Here you see 7.5 has a greater absolute value than -1. So we know the sum of these two addends will be positive. 7.5 plus -1 is the same as 7.5 minus 1, which is 6.5. Here we have another sum of two values that have opposite signs. Which has a greater absolute value? 6.5. So our sum will be positive. What is the difference of 6.5 and 3 7/75? The difference of 6.5 and 3 7/75 is 2 7/75. Our sum stays positive because 6.5 has the greater absolute value and it's positive. We need to recognize that the absolute value is a grouping symbol. We follow order of operations and use properties of operations to simplify and evaluate numeric expressions. Here we have one set of grouping symbols. It's the absolute value symbol. The parentheses here are just to visually separate the multiplication from the negative symbol in front of the 1. To find the absolute value of -3 minus 2 7/10, first we need to find the difference of -3 and -2 7/10. Finding the sum of two numbers that have the same sign, you add the absolute values and keep the sign. 3 plus 2 7/10 is 5 7/10, and we'll keep the negative. The absolute value of -5 7/10 is positive 5 7/10. Now we need to find two products. In order of operations, multiplication comes before addition. So we'll find the product of -2.5 and 5 7/10, as well as the product of 6 and -1.5. The product of a negative and a positive rational number is negative. The product of 6 and -1.5 is -9. Now we have the sum of two negative numbers. We know the sum will be negative. 14 and 25/100 plus -9 is -23 and 25/100. Remember, absolute value measures how far a number is from 0. On a horizontal number line, whether it's negative or positive, you're measuring how far it is from 0, and distance is always positive. On a vertical number line, it's the same thing. If the number is positive, it's how far it is away from 0. If the number is negative, it's just how far away it is from 0. Absolute value is always positive, and the notation for it is those two vertical bars. Canella and I thank you for tuning in to another Muddy Math video. Don't forget to give this video a like, hit subscribe, and in the comments below, let me know what concepts are muddy for you, and I'll clear them up.